In the Western Ghats Mountains, there is a cliff face, like thousands of other cliff faces in India, layered basalt, weathered by monsoons. Unremarkable, except for one thing. Someone carved it into a temple. Not on the cliff, not into the cliff. From the cliff, top to bottom. Outside to inside, removing 400,000 tons of rock to reveal a complete 3D structure beneath. The Kailasa Temple, the most impossible building ever attempted on Earth. Imagine a temple the size of an ancient Greek stadium, 270, 300 feet long, 150, 175 feet wide, over 100 feet high. Now imagine that entire temple is not made of stones stacked together. It's carved from a single connected piece of rock. One mountain, one temple. One monolith, pillars, part of the same rock elephant sculptures, part of the same rock, bridges, part of the same rock, shrines, part of the same rock, everything. Every surface, every carving, every architectural detail is connected to everything else. Remove one wrong piece and the entire structure could collapse. Carving a temple from a single block requires seeing the finished product before you start. If you're stacking stones, you can adjust, modify, repair mistakes. But carving from one block, you see the rock, you plan the temple, you start cutting, and you cannot make mistakes. Every hammer blow either creates the temple or destroys it. Local records and Sanskrit inscriptions claim the temple was carved during the reign of King Krishna I of the Rashtrakuta dynasty. That reign lasted approximately 18 years, from around 756 AD to 774 AD. 18 years to remove 400,000 tons of hard basalt rock and create one of the most complex structures in architectural history. Modern engineers say this is nearly impossible. Even with today's equipment, a project of this scale would take decades. Yet ancient records insist it was completed in less than 2 decades, using hammers, chisels. Human muscle, no machinery. This is where conventional construction logic breaks down. When you build a structure, you build from the ground up. Foundation first, then walls, then roof. If something goes wrong, you adjust. Reinforce. Repair. But Kailasa was built from the top down. The workers stood on the cliff peak and started removing rock. Downward, deeper, creating a void beneath their feet. Imagine standing on a roof and removing the walls beneath you. That's what happened at Kailasa. Workers carved away basalt from above, creating a massive courtyard, shrines, pillars, all while standing on increasingly unstable ground. One structural miscalculation and the entire cliff section could collapse. Workers would be crushed, years of work destroyed. The project abandoned, yet it didn't collapse. Before the first strike of a hammer, someone had to visualize the entire structure, not just the temple itself, but the load-bearing walls, the structural supports, the weight distribution. The architect had to know, if I remove this section of rock, will the section above it remain stable? If I create this void, will surrounding rock hold? This requires three-dimensional thinking at a scale almost impossible to comprehend. You're not drawing blueprints, you're carving into a mountain. Every decision is permanent. The Kailasa Temple has walls that are sometimes just a few feet thick, supporting thousands of tons of rock above them. One miscalculation, one wall cut too thin, and catastrophic failure. The wall cracks, the weight above shifts. Collapse cascades downward, yet every wall at Kailasa remains intact, still standing after 200 years. This suggests not luck, but knowledge, calculation, understanding of structural dynamics. Basalt is hard. Harder than granite in some ways, brittle. When you strike it, it doesn't always break cleanly. Sometimes it shatters. Fragments spray. Working with basalt at this scale is like sculpting with explosives. You have to understand how the rock will respond to impact, how it will fracture, how it will settle. One wrong blow and a massive piece breaks off unexpectedly. Workers are injured. The structure is damaged. Ancient tools were simple: hammers, chisels, possibly copper or bronze implements. These tools dull quickly on hard basalt. Workers would need to constantly replace them, sharpen them, forge new ones. Where were they making these tools? How many did they need? Archaeological surveys show tool-making workshops existed at Ellora. Evidence of hammers and chisels discovered. But the scale suggests industrial-level tool production. This wasn't artisanal craft. This was factory-level output. Removing 400,000 tons of rock creates dust, massive amounts, clouds of stone dust that would choke workers. Obscure vision, get into everything. How did ancient workers survive in that environment? Water systems would be needed to settle dust. Ventilation systems to clear air. Archaeological evidence suggests water channels existed at Ellora for this purpose. The builders understood that you can't carve a mountain without managing the byproducts. Where does 400,000 tons of rock go? It has to be moved somewhere. Removed from the site. Was it used in other buildings? Stacked nearby? Dumped into valleys? Some scholars propose it was quarried and used in other structures. But that would require transport systems, coordination with other construction projects, an organized network of workers and engineers. As they carved deeper, the temple design evolved. You can see this in the final structure. Some sections are less refined than others. This suggests they learned as they went. Adjusted technique, improved method. But with a permanent medium like rock, adjustments are limited. You can't easily fix a mistake by carving something else. Yet the temple was successfully completed. All common 200 years of it standing. Thousands of workers coordinated over decades. How? No written project management systems existed. No blueprints transmitted by email. Yet somehow, workers who never studied the master plan knew where to cut. How was knowledge transferred? Oral instruction? Demonstration? Apprenticeship? How did you maintain consistency across years and shifts when workers changed constantly? If 10,000 workers each removed 40 tons of rock per year, you'd remove 400,000 tons in 1 year. But that assumes perfect efficiency. No rest days, no tool replacement time, no accidents, no sickness. Realistically, it would take much longer. Yet records claim 18 years. Either the workforce was much larger, or the efficiency was extraordinary, or the timeline is exaggerated. Standing inside Kailasa Temple, surrounded by perfect carvings and intricate architectural details, one thing becomes clear. This wasn't trial and error, this was precision engineering. Whoever planned this had done something similar before, or possessed extraordinary architectural knowledge. They knew what they were doing before they started, and they executed flawlessly for nearly 2 decades. What knowledge allowed that? Where did it come from? This is the question nobody asks. When you carve a temple from a mountain, you remove an enormous amount of rock. 400,000 tons. That's not disappearing. That's not vaporizing. It has to go somewhere. And the answer reveals something unexpected about Kailasa's construction. Imagine a rectangular block, 300 feet long, 175 feet wide, 100 feet high. That's roughly the volume carved out of the mountain. In cubic feet, that's approximately 5.25 million cubic feet of rock. Basalt weighs about 180 pounds per cubic foot. That's roughly 400,000 tons. Exactly as estimated. But where is all that rock? Some scholars propose the rock was quarried and used in other structures. But there are no nearby massive stone structures built at the same time as Kailasa. The Rashtrakuta dynasty built temples elsewhere in India, but none requiring 400,000 tons of stone. Where would they use this volume of rock? Other scholars suggest the rock was simply stacked nearby or dumped into valleys. Archaeological surveys have found unusual rock piles near Ellora, possibly quarry waste. But moving 400,000 tons of rock would require transport infrastructure. Roads, carts.animal teams. Organization evidence of this infrastructure hasn't been clearly identified. Some propose the rock was moved along constructed ramps, downslope from the quarry toward valleys below. This is plausible. Gravity assists. Water channels could smooth the path. But it still requires enormous logistics, teams of workers, days or weeks of continuous transport. Coordination. Here's a stranger proposal. What if the rock was moved underground? Ellora is honeycombed with caves. some natural, some carved by hand. What if workers moved quarry debris through underground passages? Some scholars have proposed that Ellora's cave complex serves as an underground network. The rock could have been transported through these caves to distant dumping sites. This would explain why there's no obvious nearby quarry debris. Another possibility: the rock was crushed and reused, broken into smaller pieces and used as fill, gravel, or aggregate in other construction. Crushed stone mixed with other materials to create building foundations or roads. This would distribute the 400,000 tons across multiple projects, multiple locations, making it nearly invisible in the archaeological record. If you had to manually remove 400,000 tons of rock using only hammers and chisels, you'd need 10,000 workers removing 40 tons per year each, or 5,000 workers removing 80 tons per year each. Or some combination, but that assumes continuous, perfect efficiency. In reality, there would be accidents, injuries, tool breakage, weather delays. Real efficiency might be half of these estimates, which means either the workforce was massive or the timeline is compressed. An often overlooked problem: dust management. Carving basalt creates fine dust, silica dust, dangerous to breathe. Workers would suffer silicosis, lung damage, reduced productivity over time. How did they manage this? Water channels to dampen dust, cloth wraps over mouths, ventilation systems. Archaeological evidence suggests water systems were sophisticated at Ellora. But did they really have hazmat protocols 200 years ago? Carving a mountain creates noise, constant hammering, echoing through valleys. Carrying for miles, thousands of workers striking rock simultaneously. The noise alone would be overwhelming, disorienting. Yet Ellora's canyon geography might have channeled or absorbed sound. Still, the acoustic environment must have been brutal. Moving 400,000 tons of rock requires organizing thousands of people, feeding them, housing them, paying them, rotating shifts, maintaining morale over nearly 2 decades. This isn't a small-scale project. This is a nation mobilizing resources. The fact that this was completed suggests extraordinary social organization. A civilization so unified and directed that it could sustain a massive public project for generations. What was the economic impact of this project? If 10,000 workers labored for 18 years, that's 180,000 worker years of labor. That's an enormous portion of a nation's economic output dedicated to one temple. Why? What was the return on investment? Religious faith, prestige, architectural ambition? To dedicate that many resources to a single structure, the motivation must have been extraordinary. The rock had to go somewhere. Either it was used in other structures, but we don't see evidence, or it was moved away systematically, but we don't see the infrastructure. Or it was crushed and distributed, but we don't see the locations. Or it remains at Ellora, but we don't see massive debris piles. The fact that 400,000 tons of rock essentially vanished from the archaeological record is strange. Either the rock was managed with extraordinary efficiency, or we're missing something about how it was handled. Before the first chisel struck basalt, someone had a vision, a complete 3D temple in their mind. Before the rock was touched, this is the real mystery of Kailasa. Not the carving, not the labor, not the tools, the planning. The pre-visualization problem. Imagine trying to design a building inside a solid block. You can't see inside the block. You can only imagine what's there. One mistake in your visualization and you carve into a load-bearing wall. Suddenly, the structure becomes unstable. Collapse risk increases. Yet the architect of Kailasa got it right. The temple is perfectly balanced, structurally sound, aesthetically proportioned. On the first attempt, the proportional harmony. The Kailasa Temple follows mathematical principles. The ratios between sections follow geometric harmony. The placement of pillars, courts, shrines, all proportionally balanced. This isn't accidental. This is deliberate design following architectural rules. Ancient Indian architecture had strict proportional systems called Vastu Shastra. The structural knowledge. The temple's walls are thick enough to support the weight above. The supports are positioned to distribute load efficiently. The arches and vaults curve in ways that distribute stress appropriately. This requires understanding of structural mechanics. Ancient engineers didn't have calculus, didn't have stress analysis software. Yet they understood, intuitively or through experience, how to build something this complex. As the temple was carved downward, the architect had to imagine creating interior spaces, courtyards with specific dimensions, shrines at particular depths, passages with calculated proportions. Yet it all balanced perfectly. The temple also includes elaborate sculptures, elephants, deities, narrative reliefs. These aren't randomly placed, they're part of the architectural design. The architect had to know, before carving began, where each sculpture would go. Most architects design in 2 dimensions, floor plans and elevations. But Kailasa had to be designed in 3 full dimensions. How surfaces relate, how spaces flow, how weight distributes. This suggests either extraordinary genius or a system of design we don't fully understand. The temple exhibits multiple axes of symmetry, bilateral, radial, and hierarchical. Creating such complex symmetry while carving into a solid block requires absolute precision. One off-center cut and the symmetry is broken. Yet it remains perfect throughout. Some scholars propose the architect built scale models first, wooden or stone mock-ups. This would explain the precision. But no scale models have been discovered. Once the plan was finalized, how do you communicate a 3D design to thousands of people? Despite the rigid planning, the temple shows evidence of adaptation. Some sections are less refined. This suggests the design wasn't absolutely rigid. Workers had some flexibility to improvise within a framework that ensured overall coherence. Could one person design something this complex? A single architect who held the entire 3D vision in their mind? Historical records credit King Krishna Y as the patron. But who was the architect? No name survives, just the temple. Perfect, complete, anonymous. The real question isn't how they carved it. It's how they planned it. How do you communicate that vision to 10,000 workers, ensuring they all understand their role? This suggests a level of organizational genius that equals the carving genius. A civilization capable of coordinating thousands of people toward a unified vision. That's rarer than the engineering. That's the real miracle. On paper, the story sounds simple. The Kailasa Temple was commissioned by a Rashtrakuta king, most likely Krishnadhwat in the 8th century CE. His reign lasted roughly 17 to 18 years. Many sources claim the temple was completed within that single reign. One king went one project, 18 years. But when you stand in front of Kailasa, that claim feels impossible. You're looking at a monolithic complex about 276 feet long, 154 feet wide, and 107 feet high. Over 400,000 tons of basalt removed from the mountain. 18 years starts to look very small. So how long did it really take? Some art historians argue the 18 years refers only to the core phase, the main shrine, Nandi Mandapa, lower courtyard, elephants, and primary gateway. Finishing details could have been added later by successors. That still means one generation carved the mountain into its main recognizable shape. An insane acceleration of labor and organization. Others believe the construction stretched across multiple reigns, even multiple centuries. The broader Ellora complex evolved from the 6th to the 10th century CE, with Buddhist, Hindu, and Jain phases. In that view, Kailasa may have had a longer, multi-generational gestation, far beyond any single king's reign. But here's the catch. The style of the core Kailasa Temple, its main layout, its elephant frieze, its primary sculptural language, feels remarkably unified. It doesn't look like a patchwork of centuries. It looks like one huge, coherent idea executed with consistent vision. That suggests one dominant design phase and one intense burst of excavation, not scattered over hundreds of years. Then there's the math. Some modern estimates suggest that if a single worker removed about 4 cubic feet of rock per day, A few hundred highly organized laborers could, in theory, complete the bulk excavation in under a decade. So now you have a paradox. Visually, Kailasa looks too complex for 18 years. Mathematically, a focused crew could achieve shocking progress in under 20. Stylistically, the main body looks like one unified project. It feels like the truth lives in between. A massive, insanely intense primary phase, driven by a king who wanted to leave something that would outlive empires, followed by decades of refinement. Which leads to a deeper question. Why the rush? Most temples can be expanded or rebuilt. Kailasa can't. You get one attempt. Choosing that method, top-down, one piece, no second chances, implies an urgency we don't fully understand. Maybe it was religious devotion or a king obsessed with immortality. But the result is clear. Whether it took 18 years or 100, Kailasa represents a concentrated, all-in bet from a civilization that decided, we will turn this mountain into a temple, no matter what it costs. And they did. Here's the simplest question that reveals the deepest mystery. If ancient India could carve Kailasa in the 8th century, why hasn't any civilization since attempted something similar? After Kailasa was completed, other monolithic temples were carved in India, but none match its scale. They're smaller, simpler. It's like watching a civilization reach a peak and then retreat. Through the medieval period, temple construction shifted entirely to assembled stone blocks. This method is less durable, but it's safer. With assembled stone, mistakes can be undone. With a monolith, mistakes are permanent. When Europeans encountered monolithic structures, they possessed superior tools but never attempted it at that scale. They calculated the risk-reward and said, not worth it. Monolithic construction is spectacle, not practical engineering. Today, carving massive monoliths is essentially forbidden. Heritage laws, safety standards, and environmental regulations make it legally impossible. Carving Kailasa caused immense environmental impact: 400,000 tons of rock removed, dust clouds, landscape alteration. Today, the project would take a decade just to get permits, by which time budgets would have tripled and enthusiasm would have evaporated. Here's the disturbing implication. Kailasa represents knowledge that has been lost. Not knowledge of how to carve, but knowledge of the organization and sheer will that made it feasible. Ancient Indian civilization had something we've lost: a willingness to invest enormous resources into a single, monumental goal. Kailasa also required extreme risk tolerance. Modern civilization is risk-averse. We want insurance, redundancy, and exit strategies. They committed with no backup plan. Building Kailasa also required a society unified around a single vision for decades. Modern society, with its labor rights and regulations, can't maintain that level of cohesion. Furthermore, Kailasa was built to honor Shiva. Modern construction is secular and profit-driven. Nothing unifies us the way religion unified those workers. Modern economists would evaluate Kailasa and say the return on investment is poor. Ancient civilization thought differently. Some things were worth doing regardless of utility, because they were sacred, because they proved what was possible. Even today, we struggle to maintain the monuments we inherit, let alone create new ones. We haven't replicated Kailasa because we can't. Not technically, we have better tools, but we lack the will, the cohesion, the risk tolerance, and the faith. We've become efficient, practical, and risk-averse. They became legendary, and Kailasa is the proof. Kailasa Temple exists for one reason: to teach. Not through words or inscriptions, but through the pure fact of its existence. It teaches commitment. A civilization looked at an impossible project and said, "We will do this." We've lost that. Modern civilization is tentative, always hedging. We start projects with exit strategies. That mindset prevents monoliths. It teaches vision. One architect held a complete 3D vision and transmitted it to thousands of workers for nearly 2 decades. That requires exceptional trust. Modern leadership is fragmented. We can't align 10,000 people toward a unified goal anymore. It teaches permanence. The builders made something that would outlast empires. In a world obsessed with quarterly profits, this is radical. We built things designed for obsolescence. Kailasa was built for eternity. It teaches calculated risk. The builders knew mistakes were permanent, yet they proceeded. Modern civilization is paralyzed by risk. Kailasa teaches that sometimes you leap without knowing you'll land. Finally, it teaches that meaning matters. The temple wasn't built for profit or utility. It was built because something greater demanded it. Modern civilization has forgotten this. Nothing we build will outlast us, because nothing we build is built to. Standing in front of Kailasa, one question becomes unavoidable. What are we building that will outlast us? In 200 years, our skyscrapers will be ruins, our digital data inaccessible. What we'll have we created that says, we were here, we mattered. Kailasa is also a warning. The Rashtrakuta dynasty that built it is gone, but Kailasa remains. A voice from a dead civilization saying, we existed. Will anything we've built survive? History shows a pattern. Civilizations rise, create monumental things, then fall. We're in a cycle too. The Rashtrakuta rulers chose to carve a mountain. That choice defines them for eternity. We're making choices too, every day, that will define us for future generations. Or they won't, because we'll be forgotten. Kailasa stands because one civilization decided that some things matter more than practicality. The question is, are we listening? Will we create monuments, or will we fade away? Kailasa has already answered. What will our answer be?